Hi, Blake. It's, I think you're muted, but that's okay. It's nice to meet you because I know we've met before, but I was off camera that time. So it's good to see you again. And this is Danielle Garcia, who's also with Bayou City Waterkeeper and will be helping make everything run smoothly and has her eye on the mute all button in case we need it. And we're going to have just like a little intro slide to get started, and then I'll give a brief intro and then hand over the controls to you. And in just a moment here, once we get our intro slide set up, Danielle will start letting people into the, maybe right at noon, let people into the Zoom room. And we'll take a couple more minutes to let people trickle in, and then we'll get started. Any questions before? You're muted. You're.
There, that's better. Yeah, I've got my PowerPoint on slideshow. So when you turn it over to me, I just share my screen. Is that right? Okay.
Yeah, that's right. Great. Well, thank you. I'm going to go grab some water, and then we can start getting started.
Okay.
Hi, everyone. As you're trickling in, we're just going to take a couple minutes to let everyone get in. There've been there's 60 registrants in this. Hang on a second.
I don't think it's
No?
okay. That is me.
Okay, good.
Okay.
We got it. So we're going to take a second to let everyone in. We've got possibly like more than 60 people attending today. So we need to get them admitted, and we're going to get started in just a couple minutes here. In the meantime, if you want to drop in the chat your name and where you are, any affiliations you have, and answer the check-in question that's up on the slide, that would be great. And the question is, what is a place in our region that's special to you?
Hey, how's everyone doing?
Hello, welcome.
Hello, how's everyone?
Hi, Miss Doris.
How you doing?
Good. It's good to see you here. We're just letting everybody get into the Zoom, and we'll get started in just another couple minutes.
Okay, that's fine. Internet acting crazy, so I'm keeping the picture off a little bit.
That works.
It's been cold here in Houston, huh? Some cold weather.
Yeah,
I'm loving seeing these responses. I see Trinity Bay. Someone said everything about our region makes it special. Buffalo Bayou. Pine Gully Park in Seabrook.
Unfortunately, I don't see how to answer that question. This is David Burkett.
Yeah, so at the bottom of the screen, you should have depending on how you're logged in, there should be a chat button. And if you click that button, it says type message here, and you can just add your answer there. Or since you're off mute, you can just tell us your answer also.
Oh, North Jetty.
Thank you. The entire stretch of greenways stretching from Buffalo Bayou west, east, and north. I like that too. Great. So let's get started, and feel free to keep dropping answers in the chat if you want to. But thanks everyone for being here today. This presentation is part of an ongoing learning series to help the public understand the $31 billion project we often call the Ike Dike. Our first presentation gave a broad overview of the project, sharing aspects of its key features and key concerns of advocates and actions we can take on a shorter timeline to address climate risks in our region. Our second presentation focused on key decision makers currently playing a role in moving the Ike Dike forward. Danielle Garcia with Bayou City Waterkeeper will share links to those presentations in the chat. She'll also share a link to our email list where you can learn more about future presentations like this one that are coming up in 2023 and opportunities to take action, and also read a small collection of related news stories that we think might be of interest to you. So as we begin, I just ask that everyone go on mute if you're not on mute already. We'll be, keeping an eye on everybody and trying to keep us muted. But we set it up this way because we do, there will be an opportunity to have questions and answers, and we want people to be able to, participate and not have to have their voice filtered through us. So help us with that by just making sure you're muted, or we'll help you mute yourself. Today, so we're going to focus on something a little bit different than we have so far, and that's the petrochemical industries along the Port of Houston and how they're vulnerable to climate risks, and in particular, storm surge. Those of us who have lived in this region for any stretch of time are aware of the presence of the industries all around us. These industrial facilities drive parts of our economy. They also create risks for us too. Some of us work along the port and are able to support our families through that work. That's why I'm in Houston. That's where my dad worked when I was growing up. Some of us live in the shadow of refineries and experience higher rates of cancer and respiratory problems as a result. Most of us were more acutely aware of these harms when the ITC terminal blew up in Deer Park in 2019. And all of us, whether we know it or not, were affected by air and water pollution associated with these facilities more days than not. And during major storms, the risks these facilities present are seriously heightened. One rationale for the Ike Dike has been to protect us from a major disaster caused by these facilities during storm surge associated with the Category 3 storm or less. The protections that have been proposed will not be in place for another 20 years. And it's important that we understand what the Ike Dike purports to do and that it will actually work, but also not lose sight of alternatives that might be able to be pursued on a shorter timeline. So I invited Blake Eskew, our speaker today, because he has researched how infrastructure is vulnerable along the Port of Houston. Mr. Eskew is a contractor to the Rice SSPEED Center who specializes in analysis of the energy and petrochemical industries. As we listen to Mr. Eskew and learn from his slides, I'm holding 3 questions in mind, and I'm just going to share them with you in case it's helpful for you to think about them too as you listen. So first, how vulnerable to storm surge are industries along the port? How serious are these risks? Second, is the Ike Dike the right answer for addressing these and broader climate risks? And third, what does it mean to talk about protecting industrial facilities along the port 20 years from now, when we're also working to end our reliance on fossil fuels along the same timeline? Before handing over the controls to Mr. Eskew, just some quick notes on logistics. Just going to reiterate, mute yourself if you're not muted already. Second, we'll have space to ask questions at the end of Mr. Eskew's presentation, but also feel free to drop questions in the chat as you have them. And third, if you have any technical issues, please, that you need help with, please go ahead and send a direct message to Danielle Garcia. And Danielle, I don't know if you want to wave hi so people see where you are on their Zoom. And that's it. So Blake, I'm going to turn this over to you. I look forward to watching the presentation.
Okay, thanks, Kristen, and please do call me Blake. Most people, I traveled a lot internationally, and I get called Mr. Blake, Mr. Eskew, but my first name is Blake, and I always answer to it. So thanks. I'll go ahead and start my screen sharing here if I can figure out how. Let's see. There we go. I think that's it. Okay, I think that's it. Again, thanks for the introduction. I'll give you a little bit more background on who I am and why I'm doing what I'm doing. But I was originally a chemical engineer in college. Spent first job out on the ship channel at the ethyl plant in Pasadena, after a couple of years of working in industry, I went back to graduate school. I got a business degree, and then I spent about 7 years with Conoco in the energy industry, and about 30 years as a economist and I'd say an industry economist, focused on the primarily the refining and petroleum downstream industry, but also the petrochemical industry, with a small consulting firm called Pervin Gertz, who later sold ourselves to a much larger firm, IHS Markit. And I retired from IHS a couple of years ago, and since then I've been working with a group at the SPEED Center that's very focused on the vulnerability of the Houston area and the Port of Houston area to storm surge and other risks from major storms. It was kind of funny when you look back. How did I get interested in that? Well, I'd say when I first woke up to it was Hurricane Allison, or Tropical Storm Allison, which many of us remember. Lived in Houston for many years. We've been through lots of storms. But one of my real wake ups was after Hurricane Ike, when I pulled up the New York Times and website and saw the building I worked in on the front page of the New York Times, with half the glass along one facade knocked out by airborne debris after Ike came through downtown Houston. And so it's been a sort of an ongoing interest of mine, and it's been great to be able to work with the SPEED Center and try to do something to make a little contribution to helping make our area and our industry a little safer. So let me jump into it, and look forward to all the questions, and I'll let the waterkeeper team decide how we're going to answer those, whether we interrupt, but clearly if there's something that needs clarification at the time, please interrupt me, and we'll jump into that. First, I do want to say that the Ike Dike, the coastal barrier, whatever you want to call it, the Corps of Engineers project, is a very important project. And the SPEED Center team, the rest of us who are involved in in kind of this subject matter are strong proponents of the coastal barrier. The problem is the coastal barrier by itself is not really enough to protect our region. What I'm showing here is a storm surge flooding depth chart that was developed through some modeling that was done by Clint Dawson at the University of Texas, working with the SPEED Center. looking at the flood height and the storm surge height that would inundate areas along the upper part of Galveston Bay with a Category 5 hurricane with a trajectory not unlike Ike, a little bit further west, but a significant storm. And the problem that is not caused by the coastal barrier, that's not fully addressed by the coastal barrier, is first, as Kristen mentioned, the Corps of Engineers design criteria are somewhat conservative in terms of not being able to plan for the most significant future events and to build to mitigate the most significant future events. And so as a result, particularly strong storm surge is likely to overtop the coastal barrier, the dunes that would be built along Bolivar and Galveston Islands, other elements of the coastal barrier plan. And then so you have water that would come from the Gulf into the bay. But then on top of that, the bay, as we all know, has a lot of water in it as well. And as a hurricane moves across Galveston Bay, it will create significant additional surge volume, picking up the water that's there in the bay. And so this modeling that was done just illustrates that you've got areas that would have up to 8 feet or 8 feet or more of storm surge. You have areas that are 4 to 8 feet, some areas below 4 feet, but still significant areas of the western shore of Galveston Bay, all the way up through Morgan's Point, up into the San Jacinto River, and up Buffalo Bayou and the Ship Channel, all the way close to downtown Houston. So this modeling was done a couple of years ago. Again, this assumed that the coastal parts of the coastal barrier were in place. So it modeled the dune structure, the navigation gates, those elements. It did not include the Dickinson Bayou and Clear Creek gates that are part of the Corps of Engineers plan. For one, as you'll see in a little while, the reason this modeling was undertaken was to be able to evaluate what the residual risk is along that upper part. But in the analysis that I've done, we have not included any damage estimation or analytics west of Highway 146, with one exception. The Bayport Ship Channel and Bayport Industrial Area is quite vulnerable. As you can see, it's this, I don't know if there we go. Yeah, up in here, you've got a significant area where water can come up the Bayport Channel, move through the Bayport area into upper parts of Taylor Lake and put a lot of industrial facilities at risk back in that area as well. So we did include those in this analysis. Now, certainly in a storm like this, the Texas City area, areas further south in Galveston County would be vulnerable as well. Those were not included in this analysis, but are a big piece of the infrastructure that needs to be protected. And in our view, the best way to achieve that is probably through increasing the height, increasing the effectiveness of the Texas City Dike and levee complex. Let me move on. So this is another picture. The first one was flood heights, and this one takes those same areas that would be potentially affected by storm surge and from this Category 4 or Category 5 hurricane, and says what kind of properties are there? How many is there anything there? And what kind of stuff is it? And so we've gone through and looked at based on the Galveston and Harris County tax roll data, what tax roll properties are within the area that's potentially affected by this Category 5 storm surge. And we've identified at this time, about 15,000 individual properties. About 13,000 of those are residential, 575 are industrial, 1,200 of those properties are commercial properties. The way we identified what was being used or how that property was being used, Galveston County's tax roll data actually identifies those three categories. In Harris County, we've gone through and looked at satellite imagery. We've looked at company reports, whether it's operations. We've looked at other sources of land use information, air control board records, and those kind of things. To be able to classify what these properties were in terms of industrial, residential, or commercial. And then, as you see, I've done a lot of work going through the industrial properties and evaluating what they're being used as and what's on those sites. So just as you'll see, the San Leon area here has a very big residential area that's vulnerable to storm surge, and then up here, Shore Acres on up into LaPorte has other significant residential areas that are still in the danger zone. But again, we'll talk about some of the residual risks that those areas face in the event of a storm like this from their exposure to industry, but we really haven't yet focused on the value or the vulnerability of those structures, but they are significantly at risk. So I said we identified 575 individual industrial properties as defined on the tax rolls. But many of these large industrial sites they were built up over many years. There are a number of different tax roll properties included in those. So we kind of honed it down into what are how many actual facilities are there, and those 575 properties boil down to about 160 different industrial sites. Again, most of which have multiple tax roll facilities. We identified what those facilities were by looking at whether it's satellite images, street view images, maps, company information, media reports, just any kind of data we could find. And as you all know, these industries are very, very large contributors to the vitality and the economic performance of this entire area as well as the nation. When you look at the refineries that are in this area, the petroleum refineries, they account for something like 13% of U.S. refining capacity. When you look at some of the specific petrochemical products that are produced in these facilities, it's in the order of 20 or 25% of total U.S. production of those petrochemicals. Whether it's polyethylene, other olefins, polyolefins, and so there's a very large economic contribution. These things contribute to the security and viability of really pretty much everything we do. And again, Krista mentioned the energy transition that we'll be going through for the rest of our lifetimes. But when you look at, say, electric cars, as they replace internal combustion engines, we will certainly see demand for gasoline be affected. But when you look at what those cars are built out of, it's tremendous amounts of high performance polymers that are produced by the petrochemical industry. And so really, making this transition is going to require materials that are produced from fossil sources to be able to develop those, whether it's wind turbines, electric vehicles, or any other technology. The performance attributes of advanced materials produced through petrochemical operations are really going to be essential to having them be able to make their contribution. But
sorry to,
yeah,
I wasn't going to interrupt you, but since you brought that up, then I thought it'd be good to just ask a follow-up question, because I think the question of timeline is something that I'm focused on, you know, because even just looking at the Ike Dike itself,
Right.
it, you know, if it moves forward, it's planned to be finished 20 years from now. And a lot of, you know, those of us who are doing climate justice work and are involved in climate action plans are, you know, really working toward phasing out fossil fuels over that same timeline, if not sooner. And so, you know, that's where I feel like there's a disconnect between these plans and sort of climate, you know, climate action plan, like, sorry, these plans related to the Ike Dike and then climate action plans. Could you speak to that a little bit more?
Yeah. I mean, it's when you look at the goals, whether it's a COP27 or you know, various you know, corporate net zero targets, 2050 is generally the, you know, the time frame that is being set for, you know, achieving a net zero carbon emission profile to be able to you know, keep the increase in global temperatures to a sustainable, to a survivable level. You know, what net zero means is that, you know, our emissions of carbon are going to be offset by reductions in other ways. You know, that we get to a level where the natural absorption of carbon emissions, as well as unnatural absorption of carbon through sequestration or other technologies would offset those carbon emissions. And so you'll still have carbon being emitted. I don't think, again, given that the technologies that will help us get there, you know, the replacement again of you know, fossil fuel power plants with renewable sources, you know, requires huge amounts of advanced materials that are likely to be produced by petrochemical plants. Again, whether they are, you know, their feedstocks are biomaterials or fossil fuels is still kind of up in the air, but we will still have a need to produce advanced materials and liquid fuels for airplanes, I would believe, and many other forms of transportation. And so, you know, I understand, you know, the facilities that are in the Port of Houston area may be making different products 30 years from now than they make now, but I still think those kind of facilities will be vital, you know, will be part of our everyday life just as they are today. I'm not sure if that fully answers your question, but that's again the way I look at it. And the, you know, the Ike Dike timeline is in the as you say, 20 years. The latest stuff I've seen is, you know, has completion around 2040. You know, at that point, we'll still have a pretty significant fossil fuel industry. And there's other projects, in particular the project that the SPEED Center is working on, as we'll see in a few minutes, that could be completed on a much shorter time frame.
Thank you.
Okay, so what I've done is to look at these industrial facilities and try to categorize, you know, what they are, what takes place on those sites, and again, to be able to evaluate the risk that is posed to those facilities, and conversely, what the risk those facilities pose to the environment, and excuse me, in the event of the right kind of hurricane. And so, out of those 160 industrial sites, I classify just under half, about I think 79 of those 160, I classify as hydrocarbon sites, as a general catch-all category. That includes sites that have petroleum refineries on them, sites that have petrochemical production on them, sites that have petroleum storage and terminaling, sites that have petrochemical storage and terminaling, and then biofuel sites. You know, many sites have, you know, all four of those hydrocarbon operations. Some have only one, and so the numbers add up to more than 80. But But there are in that area, among those facilities, which our modeling indicates would be subject to some degree of storm surge flooding in the event of this Category 5, even with the coastal barrier in place. We've got 80 of almost 80 industrial facilities with these hydrocarbon operations on them. And you look at the other facilities, again, I've focused on the hydrocarbon sites, but there are bulk materials storage sites, some of those materials are hazardous as well. You have transportation and logistics sites, you have recycling facilities, you have water and wastewater treatment facilities. All of these are not only vulnerable to damage, but vulnerable to causing secondary damage should their security be breached by a significant storm surge. So focusing a little harder on the hydrocarbon sites, when you look at these facilities, they almost all have some form of above ground storage tanks for feedstocks, for products, for transshipment, for just for storage, for export, for import. And storage tanks, these are, again, primarily the cylindrical tanks that everybody's seen many of as they drive down Highway 225 or take the Beltway through on the way to NASA. We see these all over our area. They're a very efficient way to store hydrocarbon materials, but they are vulnerable to storm surge and to other environmental risks. When you look at the total number of tanks that are in the affected sites, there's about 5,800 individual storage tanks. So if I've gone through and added them up, estimated their volume, out of those total 5,800 storage tanks, have an estimated volume about a little over 10 billion gallons of hydrocarbons in storage. And this is on the sites that are potentially affected by storm surge. Now, out of those sites, we also looked at what is the, how many tanks are actually in the area that is modeled as being underwater in the event of this storm that's been modeled. And out of those 5,800, it's a little over half, so 2,900 tanks with capacity estimated at over 4 billion gallons are actually in the area that would be subject to some level of flooding from the storm surge. And I've gone through and using looking for some prior research on what's the cost of a hydrocarbon spill. Typically $10 to $20 a gallon for damage and mitigation and cleanup and recovery. Using a $10 per gallon of hydrocarbon, that's a potential exposure of up to $40 billion from damage to these tanks. When you look at above ground storage tanks, most of them are designed for fairly low pressure operation. Many are anchored, but many are not. And so you in a flood or storm surge event, some of these tanks can actually float, pick up. They'll be disconnected from their connecting piping, both inlets and outlets. They can be subjected to wind damage. They can be subjected to damage from storm tossed debris, whether it's a barge or a shipping container or the tank next to it. So these storage tanks have a lot of ways that they can become breached and compromised and damaged during a major hurricane. And we've seen these things happen. In Katrina, we saw some happen in Ike. This is not hypothetical. These are genuine risks that that certainly have affected not only the tanks and the facilities in which they're on, but neighboring areas, neighborhoods, and the areas around them, if they are breached and hydrocarbons are spilled.
Blake, I'm gonna jump in again, just because there's been a couple of comments that have come through
Okay.
that are related. And one's from Danielle Goshen at National Wildlife Federation. She asked the question, why do our regulations allow for this vulnerability? What level of protection are they required to show to ensure they aren't posing a risk to neighboring communities of the Bay? And then Bob Stokes with Galveston Bay Foundation added, EPA recently announced a policy related to inspections of vulnerable facilities and included a link there so people could learn more. And that's even EPA Region 6, where we fall, has a strategy that includes the inspections, but also includes passing better regulations to fold into permits. And so I think that starts to maybe answer Danielle's question. But I think also it's a lack of compliance issue too. I think that there are a lot of requirements that facilities aren't meeting, that if they were, we'd be, that's when we're thinking about shorter timeline answers, that's part of the answer. It may not be the whole answer, but I think that's something that I've just been thinking a lot, and it felt really relevant at this moment. So I wanted to bring it up, but I don't know if you have anything to add to that.
Yeah, I'd say that the design standards, the maintenance standards, the operation and inspection standards are really oriented towards process safety. So, is this going to fail during its normal operations and cause a disaster, or is this something that is going to contribute to atmospheric emissions? So there many aspects of tank design and operations and maintenance are limited towards reducing the amount of atmospheric emissions of hydrocarbons, to help control ozone formation in the atmosphere, as well as to maintain the integrity of tankage that holds hazardous materials. And in general, I would say the design and operations, the environmental regulations, the industry standards, they're not really oriented towards what happens in a worst case disaster. What happens if a hurricane comes and hits this thing. You do have design standards for wind loadings, based on expected levels of storms, and certainly facilities are designed for storm conditions, but they're not necessarily designed for flooding and storm surge. When you look at, say, the dikes, and anyone, again, if you've driven down Highway 225, you see the storage tanks, you'll see the dikes that surround them. Those are to control or to contain the material within that tank in the event that it has a leak and spills. It's not to protect that tank from a storm surge that would potentially lift it off its foundations and damage it. So, I'd say in general, the industry and regulators tend to design for normal things. They don't necessarily consider abnormal weather events as something that's potentially regulable. So I'm not sure if that really answers the question, but again, there is some degree of storm protection built into normal design standards, but it's probably not the same as the degree of risk that living where we do and sitting where these facilities are that they're subject to.
Thank you. And I'm going to flag one more question for you. It might make sense to you to answer it now, or it might be one that you're already going to cover, but Stefania Tomaskovich with the Coalition for Environment, Equity, and Resilience, known as SEER, asks, are there some residential properties missing from this figure? For instance, the community in West Baytown. Are those homes outside of the storm surge? Some of them seem like they'd be close enough to the water to be in the surge zone and are very close to ExxonMobil. So I'm just gonna defer to you as to how to cover that and when, but I thought it might be something you could speak to.
Right. So in Harris County, we've, included all the residential properties that were in that, in the surge zone as the modeling indicated. If you're looking at, for further into Chambers County, we didn't include anything in Chambers County. It really is only the residences that are pretty close to the coastline that are subject to storm surge. This is not inland flooding, as we had during Harvey, but this is hurricane induced surge coming up, through the waterways. Okay. But that is really a good question, because the proximity of many residential neighborhoods and densely populated areas to these industrial sites results in a lot of risk to those to those residents. And this is something that, of course, anybody who's followed the environmental justice movement, anyone who's aware of the again issues with hydrocarbon exposures is certainly well aware of the kind of the way that many of our citizens live very, very close to these industrial facilities. On the inner Houston ship channel, you look at the Magnolia Park area, the Harrisburg area, the Manchester area, Galena Park, much of Pasadena, the Carpenters Bayou area, many locations that have residences and industry, right next to each other. And when you look at the Bayport and Shore Acres area, that's I've got a detailed picture on that in just a second. That want to show you the reason I consider that a very, very risky and vulnerable area. And we'll see not only does it have the storm surge risk, but it also has a tremendous amount of surge carried debris risk because of the shipping container facilities that are located there. So if you do have a storm surge, as we've modeled, if it does cause damage to these storage tanks and other processing facilities, you're going to release hydrocarbons. They're going to move up with the surge. They're going to get pushed into up Buffalo Bayou and into the Carpenters Bayou, Vents Bayou, Sims Bayou, Brays Bayou, all the way up into well into the city of Houston. And so if this disaster were to occur, not only do you potentially risk the contamination of Galveston Bay as these materials move back into Galveston Bay, you've got the contamination of enormous areas along the shore that would be contaminated with hydrocarbons kind of on the way in and on the way out. So it's that's why we think this is a very serious problem. So let's look at a couple of these areas in detail. So this is sort of from Manchester area through western Pasadena and up into Galena Park. And what you see is here along the ship channel in the Galena Park area, there's an enormous storage complex. Several companies have very large terminal complexes there. There's a very large terminal complex on the south side of the ship channel here, next to the Lyondale refinery. You've got the Lyondale refinery with quite a bit of storage facilities. You've got the Valero refinery down here in the Manchester area. Also has enormous amounts of hydrocarbon storage, and there's other storage facilities nearby. You've got a let's see, up here north of the Kinder Morgan Galena Park terminal is the Kinder Morgan condensate processing facility, basically a small oil refinery. You've got petrochemical production all through this area. And so if you had a surge coming up the ship channel, damage to these Galena Park terminals, that material is going to get carried on up the ship channel and move up into the Vents Bayou area, the Sims Bayou area, on past Valero into the Manchester area. So again, the problem is the damage to the facilities, but the subsequent damage that releases of any of these hydrocarbons would have on all the facilities and areas around them are just as bad. Now, if you look at the Bayport and Shore Acres area, again, this is one that is really I think a very risky area. You've got the Bayport Channel and Bayport turning basin here, which is surrounded by petroleum storage facilities and a little bit of some processing, but mainly petroleum and petrochemical storage. Out at the inlet to the Bayport Channel is the enormous container port, which has containers that are stacked up, a dozen high at least. And in the event of a storm surge, as these containers are hit by a surge, they will float. They are very heavy. They typically have, contain cargo that's less dense than water, so they will float, and they can act like battering rams to impact anything in their way. Which, unfortunately, the closest thing is all these storage terminals here, right surrounding the Bayport Channel. As the if a surge comes through, you're going to push that material and push that water back into the upper parts of Taylor Lake, which is surrounded by many different petrochemical production facilities. So a huge complex down there, and all those facilities are at risk of damage from storm surge as well. And then kind of one of the consequential damages would be, as this material goes in, as the surge dissipates, the hydrocarbons floating on the water are going to come back out, and they're going to potentially end up in the Shore Acres residential zone, which is very residential, lots of houses, lots of very nice houses, but certainly very much at risk of secondary contamination from any of the spills and damage that could occur due to the storm surge.
Blake, I'm gonna interrupt one more time because we've got a lot of really smart people. I mean, there's just a lot of smart people who've shown up today that are having really good questions and comments as we go. Some of them I'm holding for the end, but like Bob Stokes, and I think he's talking about Baytown, but it may be relevant to other neighborhoods as you talk about them. So Bob, actually, do you want to explain this a little bit more?
Can you hear me?
Yes.
Yeah, so I was talking specifically about the western side of Baytown, like Burnett Bay area. A lot of those houses sit on bluffs, so they're not specifically, but certainly Shore Acres and areas that we're talking about right now don't have the same elevation. But one key thing is that there is, elevation around the bay, right? So this is all relative, right? So where our office is in Kemah, we're actually at 14 feet. So we already have some protection from storm surge, but if we have a 21-foot storm surge, we would get 7 feet of storm surge on our property. And so, a lot of the places along the ship channel that are not in the shaded areas, or in the colored areas, I should say, are not there because they have elevation. Believe it or not, like a lot of structures in the ship channel area are at like 17 or 18 feet or more. So it's the big storm would produce even higher surges than 17 or 18 feet up there. It would produce, whatever, the 25 foot surge. Right.
No, I totally agree. And this again, the modeling that we've done here that I've shown you, assumes that the coastal barrier dune structures were in place, that the Bolivar Roads navigation gate was closed, and we still have this much residual surge coming up and affecting all of these areas. I'd have to look specifically at the Baytown area to see what we modeled there, and as we move on to to our next phase of the work that we're engaged in we're going to be looking more closely at Baytown and anything else in Chambers County. So yeah, so you're all. I hope you're all waiting with bated breath as to what the what the next phase is going to be, and what the how what we can do to address this potential disaster that we have all been living with for most of our lives here in Houston. And the project that the Speed Center is working on and has been working on for several years has coalesced into something called the Galveston Bay Park Plant. And this is a project which we see as a complement or complementary project to go with the coastal barrier. This is not a standalone. Again, with the Speed Center and all of us think that the coastal barrier project needs to be built, but that we need additional protection for the industries and the residents on the west side of Galveston Bay. Again, when you look at the areas that are at risk, at the number of people, the value of the industrial infrastructure, and as well as the human infrastructure, the west side of Galveston Bay is sort of where the people are and where the money is, and that's what needs to be protected. So the Galveston Bay Park Plan concept is to widen the ship channel, potentially deepen it, but originally to widen it to 900 feet to provide additional navigation safety, to make it a more efficient and a safer industrial and commercial navigation system, to use the materials that are dredged out and widening to basically extend the spoil islands, Atkinson Islands and on down, which are roughly a third of this area, or a third of the length, to extend those islands all the way down to intersect with the Texas City Dike and levee system down at the southern end. You'd have a levee. This is a 25-foot surge barrier extending again from Texas City all the way up to Morgan's Point, with a large navigation gate for channel traffic here in the middle where those meet. You'd have smaller navigation gates throughout the island complex for recreational and commercial traffic, and that to use this project as a way to produce a very large public amenity for everybody who wants to be exposed to Galveston Bay. So using the spoil materials to build up these islands, to eventually convert that into parkland, to make that accessible at the southern end and the northern end. Again, we've it's conceptual at this point, but it's a way to take what's now largely a private shoreline surrounding Galveston Bay and create a significant public amenity and public access to the bay itself. It's I don't remember the exact number. When you look at the percentage of public access to Galveston Bay parkland and public lands versus privately owned shoreline, it's minuscule. It's very difficult for people who don't own a beach house or a bay house to actually use the bay. So this is a way to improve that access and to make sure that we all get to enjoy the water.
Yeah.
So this, go ahead.
Oh, so I was gonna, okay, you're answering this. I was gonna say that this
Yeah,
is also like at a pretty early stage in terms of environmental studies and permitting, trying to go through permitting processes and
Right. So again, the Speed Center is the primary entity that's moving this plan forward. The concept is that this is a complementary project that will complement the effect of the coastal barrier. It provides a higher level of protection for the most densely populated, the most economically active parts of the entire Bay complex. And part of what we think the attraction of this project is it could be done much more quickly. It could be done at much lower cost. We're thinking at this point something in the $5 to $6 billion range versus $30 billion for the coastal barrier project, something that would take roughly 5 years to complete versus the 20-year time frame of the entire coastal barrier project. It would also, again, as I said, we see it as a complementary project because this would eliminate the need for the Dickinson Bayou structure and the Clear Creek structures, as well as the other non-structural improvements that are part of the core project. This would provide ancillary benefits to the economy of the area, to the Port of Houston operations, improve safety through having a wider channel, and as I said, kind of keep the port positioned and capable of meeting the economic needs of the future. It would provide a huge amount of new recreational access to the bay and public access. And part of the project would be to again expand wetlands, expand oyster reefs, reconstruct and rebuild many of these environmental benefits that have been dissipated over the years, as so many parts of Galveston Bay have had their soft fringes with the bay replaced by hard barriers, whether they're sea walls, riprap walls, or whatever. We've lost tremendous amounts of wetlands and areas that mitigate not only storms but create benefits in terms of wildlife and habitat and reproduction areas. So we're right now in the process of kicking off a pre-feasibility study. We've pretty much got everything in order, waiting for a final contract to be signed, and that will provide a more accurate cost estimate, schedule evaluation, take a hard look at the environmental impacts. I'd say probably the biggest concern is the impact on salinity exchange in the bay, as well as what it could potentially do to drainage of floodwaters and another rain type event like Harvey, and to analyze how the region could pay for it, what the cost would be, what the ongoing maintenance and operations costs would be, what the how it can be financed, but also what the benefits are, to really get a good understanding of, can it be done? If it's done, what are the impacts, and how would we do it? So that's my last slide, but we can stay on as long as you'd like, and we'll go back to whatever elements anybody has any questions on.
Yeah, thank you. Thank you so much for that presentation. So part of the reason I invited Blake to come talk today is I saw some of these slides over the summer and just thought I hadn't seen this level of detail or this research. I've only heard this research referenced. I hadn't seen it in detail and thought it would be beneficial for it to be, made available to other folks too. And do you know the status of the SPEED Center making this available to the public, or like making it kind of more available in any sort of interactive or usable form by folks outside the center?
Well, we haven't really published this, but let me check with my colleagues and see what we could circulate. If you go to the SPEED Center website, there's quite a bit of information, a brochure. I think you'd recognize some of the stuff I've lifted to, particularly the next to the last slide with the picture of the park plan. So there's quite a bit of additional information there. Part of that is has been superseded. The Speed Center has been working on this for quite a number of years, and the full outline of the coastal barrier is really only been, or the coastal barrier project has really only been defined to the extent it's even now defined here within the past 18 months or so. It's there's a lot of moving pieces, but there's a lot of information out there. And again, background on the park plan is easily accessible through the Speed Center site.
Yeah, and I guess I'm like more struck by the risk assessment slides
Yeah.
too. That's what I hadn't really quite seen. And I think what also struck me about it is that when you start to, as you define what's most vulnerable and you're looking by county, sometimes the numbers have seemed insurmountably huge, but you start to get at smaller numbers of industrial facilities, that it starts to, you start to be able to think about a strategy that could happen on a shorter timeline, at least with these kind of worst facilities, the ones posing the greatest risks. So that's kind of what I got out of it. But I know Maddie Sloan from Texas Appleseed had a question. Maddie, I don't know if you want to ask it or if you just want me to ask for you.
Well, thanks, Susan. Danielle answered it for me. It was just about what kind of climate projections are being used to plan this. And I guess as a follow-up on her answer, because, medium low seems too low. Is there any way to change design standards sort of as projects move around? And I apologize, I'm coming to this a little newer than most of you. So, but yeah, how do we account for how rapidly a lot of these climate risk projections are changing? Can we?
That's a good question. And if you look at the reports that the Corps has done on the coastal barrier, they had several different scenarios for future sea level rise, which is the primary element. They didn't really, as far as I recall, there's not an assessment or any modeling treatment of sort of related issues around climate change in terms of say, are storms becoming more frequent or storms becoming more severe? It's more just looking at where sea level ends up rising to, and I think we all agree it's on its way up. In the work we're doing, we're looking at severe storms, and in our view, it's interesting to sort of contrast what the Corps' design statutes require them to do versus say what the Dutch have done in the protective structures that they built along the North Sea. When you ask someone involved in those projects or someone familiar with those projects, you can say, well, what's the design storm that this is designed to mitigate? They don't really think in those terms, but they when they figure out, they say it's basically a 10,000 year storm. That's their design storm that they've built their infrastructure to protect against. Whereas the Corps and kind of the U.S. mindset is more, it's a 50 year or 100 year at the most, and so I'm not saying that this is designed for a 10,000 year storm, and who knows what that's going to look like in 50 years from now, but we think the people of this area, the economy of this area, all of us deserve a higher level of protection than what the current design statutes are resulting in.
Thank you.
And Danielle Goshen, I know you had chimed in on that too. Did you have anything to add? It's okay if not, or maybe you're gone.
Sorry, I'm still here. I undid my video, but I didn't undo my mute. So yeah, the Army Corps was looking at an equivalent to NOAA's intermediate low sea level rise scenario. And NOAA, they, in their technical sea level rise reports, they're kind of encouraging planning for the intermediate to intermediate high scenarios for planning. So it's, you know, very, it's a scenario that they're planning for that's very likely to happen. So that's something to keep in mind when we're thinking about, you know, what level of protection this will provide and at what cost, and what more will still be needed to protect communities. Yeah, that's all I had to add.
Okay. Yeah, just, you know, the first slide there that showed the water depth from that surge, you know, was at current sea level. That did not include any estimate of future sea level rise. So, you know, obviously if you had 2 feet of sea level rise, what was a 4 foot is now a 6 foot surge flood, and on the rest. So that, yeah, so our analysis here is you know, conservative in terms of, so far, in terms of future sea level changes.
I think Madeline Crozet Williams also had a question. I don't know if you want to come off mute and ask it, or if you want to, yeah.
Yes, I would.
Mhm.
I am concerned about, particularly about the Freeport area, and somebody else asked more, actually comment on my question. The water's going to go around this barrier, Ike Dike, and it will go flowing quickly because it can't go straight. It will go around, and it will go through Surfside, and then it will go and hit Freeport and the industries in the Freeport area. There is a huge chemical industry in that area. And the flooding of those chemical industries will also create a huge environmental impact. And I'd like to know what is being considered about that. That this just doesn't seem to be addressed at all to me. And I might add that my PhD is in chemistry, and I'm really concerned about that.
Yeah, I don't really, I'll say the Speed Center work so far is focused on Galveston Bay, not on Freeport. The you know, the coastal barrier project of the Corps is, you know, pretty much limited to Galveston Bay. They do have projects that they are, you know, as part of the overall coastal resiliency plan of the GLO is putting together that addresses areas outside. I'm not personally familiar with exactly what is envisioned to protect the Freeport area. And in terms of the sort of spillover effect, I mean, I'm not a modeler. I've been using modeling results, but my understanding is that if you have the coastal barrier in place and the, you know, a storm comes up and impacts it, you know, that water would build up against the coastal barrier, and then as the storm passes, it will go back into the Gulf. And I don't think it really, you know, would result in a higher surge, or a, you know, a surge where there wouldn't otherwise be a surge, say in the Freeport area or the Beaumont area, you know, that's due to the facilities that would be in place along Bolivar and Galveston Islands.
The physics of that don't make sense. Water reaches its own level. It will have to go somewhere to go down, and it won't be going backwards. It will be going forwards to a lower level. It just seems to me like this is a big part of the picture that has not been considered. You know, it's part of the Ike Dike picture. It's not like, okay, Freeport's a separate thing because it's so close.
Right. Again, that's, I would say that's more of a question for the Corps. I know it's not a very satisfying answer, but, you know, it's not something I'm familiar with. I'm happy to see what I'll pass it on with our modelers and see what their view is on it. Okay,
thank you. Yeah, because I think it's really important.
Yeah, and in a smaller area like Galveston Bay, it's a more I'd say a more recognizable phenomenon. And certainly, and the work that the Speed Center has done, they started the first project that was envisioned was basically a gate across the ship channel down at around Morgan's Point. And when that was modeled and evaluated, the concerns were, okay, that would keep storm surge from moving up the ship channel and protect those industries, but it would do exactly as you say. It would cause secondary flooding in the areas that were outside the gate, and that's I'd say one of the prime concerns that led to the development of the park plan as it currently exists. That it protects all those areas that would be vulnerable from the surge. So part of the next phase of study will be looking at the sort of the spillover effects, because you're absolutely right. If water doesn't go up the ship channel, then it goes up someplace else, and it goes into the rest of the Galveston Bay complex. But it's a much bigger area. The topography is different, and what we've done so far is indicate that the preliminary work that's been done indicates that the impact of the Galveston Bay Park Plan on Galveston Bay and Trinity Bay throughout the rest of the complex would be in the range of 0 to 6 inches. So it's because the area is so much larger than the very concentrated area that's been protected by the park plan. The impact on water depth is very much diffused. And again, I think that's probably the answer for your question about what's the impact of the Ike Dike on Freeport in the event. It's because that the increased water level is not just at Freeport. That increased water level is over the whole of Galveston or the Gulf of Mexico, and so it's a much much more reduced height impact to account for the same volume of water.
Okay, I agree. I understand that this isn't what your group is studying, but I do see that the diffusion of the water will be over a gradient and not just suddenly leveling out to one height of water over the entire Gulf. I mean, it has to slowly go down and reach that height, and Freeport's right there.
Right, but the other thing is, the mechanics of a storm surge is that the low pressure of the hurricane, builds up the surge. So, as the surge moves forward in a very concentrated area at a high level, it basically has lowered sea level in its wake. And so if the surge hits a barrier, it'll flow back to the areas that in which sea level has been reduced.
Okay, I see what you're saying.
Yeah, yeah. The water didn't come from nowhere. The water came from the Gulf. You're picking up some water out of the Gulf and then throwing it at Galveston.
Right.
And if it can't get into Galveston, it's going to go back to where it came from. So.
Right. I'm just thinking probably modeling it. Whoever does this, modeling it would be a good idea. With some
it's an excellent point. And again, it's particularly relevant in a constrained area like inside Galveston Bay, or inside there's not another bay like Galveston Bay in Texas, but you'd have some of the same impacts if you looked at Corpus Christi Bay or some of the other coastal bays. Once you block it from one part, it's going to go someplace else. And so a key element of the analysis is, where's it going to go and how big is that impact going to be?
Okay, well, thank you.
Thank you.
Thank you for your presentation.
Yeah, thank you. I have another question that it may be totally outside the scope of what you've looked at, but somebody asked if you know anything about the impact of the proposed tunnel system on the storm surge and the coastal barrier plans.
I really don't. I mean, at this point, the tunnels are conceptual at best. I know there's been a little bit of work done, kind of coming up with some conceptual cost estimates and that kind of thing. I think one thing we are going to be doing as part of this ongoing study is to look at, what is the impact of the park plan on in the event that you close the navigation gate, you close the circulation gates because you've got a storm coming. If at the same time you have significant storm-caused rainfall, behind the gate, then where is that water going to go? How significant of an impact on drainage patterns would this have? And I think whether it's the tunnels per se would not really, they wouldn't change the amount of rainfall coming down over Harris County and adjacent counties. They would change how it moves, but one way or another it all ends up in Buffalo Bayou. So from it may change the rapidity with which those areas are drained. If you take water coming into Addicks and Barker and bypass it to Buffalo Bayou, more quickly through the tunnels than more slowly through the neighborhoods on Buffalo Bayou, as we did in Harvey, then it may have an impact on resulting flooding depths. But at this point, we haven't really had a chance to do that modeling and do that analysis yet.
Well, thank you so much for this presentation and answering these questions. I know there were folks with some more questions, but we are almost at 1:15. So it's time to say goodbye. Just kind of some reflections I wanted to share. Like I do think we need to be thinking a generation out with our plans and talking about, billion-dollar budgets. But I also think we need to be figuring out what action we can take now to make ourselves safer. The Ike Dike contemplates action 20 years from now, and we at Bayou City Waterkeeper are, asking for action that includes letting the most impacted communities shape priorities and centering their experiences in plans of action. And there's opportunities to do that soon with the Harris County's climate action plans. Reducing greenhouse gas emissions, that can't get lost in this conversation. We need to be doing that now and rapidly. No longer building in our floodplains and on our coastlines. We're always closely monitoring new permits, and you continue to see new developments right on the coast in the 100-year floodplain, even in the floodway sometimes, and outside of Harris County, and that we need to stop that. Working to keep people out of harm's way through weatherization, and making industry comply with existing regulations, and also improve regulations where needed to address, where existing regulations aren't enough. And so it may be that there's a place for these big engineered solutions with longer timelines, but I feel like it's hard to talk about them without also talking about these shorter term actions that we need to be taking. And so I wanted to lift that up. Bob Stokes shared that EPA Region 6 has announced its strategy to address climate threats. I hope they rapidly take action toward that, because increasing inspections at industrial facilities along the Gulf and incorporating climate change adaptation measures into permits, increasing enforcement on water systems violating federal rules, all of this will go toward getting us to a safer place. And that's it for today. That's it actually for 2022. Really appreciated folks for joining in on these conversations, learned a lot, and I hope that you'll continue to join us in 2023. Danielle has added a link to our email list so you can stay in touch about future presentations and opportunities to act. And just thank you again, Blake, for a really informative presentation. I really appreciate it.
Well, thanks very much. Really appreciate this opportunity. And it's great that we had a lot of interested people, and let's keep watching this space. And if there are any follow-up questions, send them on to me on one way or another, and I'll definitely try to get back with you.
Thank you. Bye, everyone.
Thanks.